6.7 is modeling with exponential and log functions, and there's only one main topic we're going to cover from the section. It's basically how to write exponential functions through given points. We have to do so by setting up a system, and you can solve that system with substitution or elimination. So we'll go over one example of each. So for example 1, write an exponential function y equals ab to the x, which is kind of the general form for an exponential, whose graph passes through the points 110 and then 340. So we're going to set up two equations using y equals ab to the x, and then we're going to take those 2 points and substitute them in for x and y. So for the first point, my x is going to be 1, my y is going to be 10. So my equation will be 10 is equal to ab to the first power, but we don't need to write that first power. We can just write it as ab. So all we did there is we took 10, we plugged it in for y, we took 1, we plugged it in for x to get our equation. Oops, sorry, erased the b. Okay, and then equation 2, we're going to do the same thing, but we're going to take our second point, which is x equals 3, and then y equals 40. So we'll take the 40, put it in for y, we'll take the 3, plug it in for x to get our second equation. So it'll be 40 equals ab to the third power. And then if we're using substitution, we have to take one equation and isolate a variable. It's typically easiest if we take either equation, doesn't matter, but isolate a. So I'm going to take the first equation and I'm going to solve it for a, and then I'm going to plug it into the second equation. So if I want to solve the first equation for a, I just need to divide both sides by b. And then I have 10 over b is equal to a. I'm going to take that a, or what I'm saying a is equal to, which is 10 over b, and then substitute it into my other equation. So it'll go right here. So when we do that, it becomes 40 equals 10 over b, and then times b cubed. And then from there, I can kind of cancel out my b's. So the b in the denominator cancels out one of my b's from the b cubed, so it becomes b squared. And then from there, we can simplify the equation to 40 equals 10b squared. And now my goal is to just isolate b. So I'm going to divide both sides by 10. And then I have 4 equals b squared. And then from there, I can square root both sides to end up with b equals 2. And you don't have to do like plus or minus 2, because for an exponential, technically like b, the base would only, or it could only be a positive number. You can't have the base of an exponential be negative, because then it makes the graph end up kind of oscillating and doesn't take that like true exponential form. Okay, so we have our b value. I can just take that now and substitute it into this equation right here to figure out what a should be. So if I do that, it'll be a equals 10 over b, which we figured out b is 2. So we're going to end up with a equals 10 over 2, which is 5. So we have b equals 2, a equals 5. We just need to take those both and now substitute them into like that general formula from the beginning to get our final answer. So it'll be y equals a first, so 5, and then times b, so 2 to the x power. And then you would not or you could not simplify the equation any more than that. Like you wouldn't multiply the 5 and the 2 to make it 10, because order of operations, you would need to simplify the exponent first before we multiply the 2 by the 5. And because we don't know what the exponent is, it's just x, we can't simplify the exponent. So we just leave it like that, and that's perfectly fine. Okay, the second one, write an exponential function y equals ab to the x whose graph passes through the points 212 and 324. So same idea, we're going to set up two equations. This time we're going to use elimination to solve our system though and figure out what a and b are. So my first equation, I'm going to use the point 212. So 2 is going to go in for x and 12 is going to go in for y. So we'll take 12, put it in for y, take 2, put it in for x to get our first equation. So it'll end up being 12 equals ab squared, and then we'll just leave it like that for now. The second point is 324, so 3 is going to go in for x, 24 is going to go in for y, so 24 for y, 3 for x, it's going to end up being 24 equals ab to the third power. And then if we want to use elimination, basically if we take one equation and divide it by the other, the a's will cancel because they're both always going to be a to the first power because the a doesn't have an exponent over it. The only thing I would usually recommend is to take the equation that has the higher power of b and divide that by the equation that has the lower power. So right now I don't want to just like divide them like that because I have the one that has the lower power of b on top. So I'm just going to switch the equations around. I'm going to call this equation 1 and equation 2, and I'll divide equation 2 by equation 1. So we'll do 24 equals a b to the third power over 12 equals a b squared from equation 1. And then we can just divide like from left to right. So if I do 24 divided by 12, that's 2. And then a divided by a, those cancel. And then b cubed divided by b squared. The two b's like cancel out 2 of the 3, so I'm still left with a b to the first power, or just b. So I end up with b equals 2. So I already have one variable now. I have b. I can just go ahead and take that b and substitute it into either of the original equations to solve for a. I'm going to use equation 1, that one that starts with the 12. So I'm just going to rewrite it up here. 12 equals a b squared, and then I'm going to take that 2 that I just got for b and plug it in. So I have 12 equals a, and then times b squared, so it'll be times 2 squared, and then 12 equals 2 squared is 4, so 4a, and then my goal is to get a by itself, so I'm going to divide both sides by 4, and then I end up with a equals 3. So I have both variables now. I can take them, plug them both into like that original kind of general exponential form equation. This y equals ab to the x, so it's going to end up being y equals a, so 3, times b, so 2, and then to the x power. And then same thing here. You would not multiply the 2 and the 3. You will never do that for these problems because you can't simplify the exponent first. You would need to do that before you go ahead and multiply those two numbers. So final answer, just y equals 3 times 2 to the x power.